A radical equation is just a basic equation, except it includes a radical on one side. And when you're solving for it, you want to make sure that you isolate the radical on the one side by adding, subtracting, dividing, whatever you need to do with the variables that aren't included, and add them to the other side so you can later solve. And if you aren't exactly sure what it means to isolate the radical, that just basically means taking away all the factors that aren't included under the radical. So for example, 2. As you can see, 2 is not included the radical, so you want to make sure that you get rid of it on both sides too, or else the equation will not be equal. So you're left with 3x plus 10 equals 5. When solving an equation, once you're left with it, you have 3x plus 10 equals 5. And you can't solve it if one side has a radical and one doesn't. So you're going to need to square both sides to make sure that they're equal. And when you square a radical, basically the numbers inside the radical aren't squared since they're already inside of a radical. They're just left alone, except the radical goes away because you're squaring it. So just a 3x plus 10. But as you can see, the 5 is not in a radical. So you need to just actually square the 5 like a regular number. And when you square 5, you get 25. And now that you have a basic Algebra 1 problem, you should be able to solve it. So, subtracting 10 from both sides will give you 3x equals 15. And then to cancel out the 3, so you have the 3 alone, you want to isolate the x by dividing both sides by 3, and you get x equals 5. But sometimes the solution that you come up with doesn't exactly work in the problem. So what you want to do is just plug it in. As you can see for the x, I plugged it in for the 5. And you're just going to want to solve it like a regular equation. 5 equals radical 15 plus 10. And you know that radical 15 plus 10 would equal 25, right? And then you have a 5. And you're going to square both sides. And yet again, if it's under the radical, stays the same. 25 equals 5 squared, which would equal 25. So this problem does work, so x would equal 5. Sometimes there's only one variable that's under the radical. So when this happens, you want to solve it just like you did in the first equation, where you're adding 4 to both sides, so you can isolate the radical. So 6 equals radical x over 6. So when you want to get rid of a fraction, you want to subtract each number by the denominator. So 6, you get 36 equals square root of x. Yet again, you want to square both sides. X, and then 36 squared. If you don't know, you can just go on your graphing calculator. 36 squared would equal 1,296. It's a really big number. Again, you need to make sure that the equation does work. So by plugging in 1,296 into my x, adding 4 to both sides so I can isolate the radical, you get 6 equals square root 1,296. 6 times 6, 6 times 6, 36 equals radical 1,296. And then you're going to want to square both sides. And yet again, 36 squared equals 1,296 equals 1,296. So this equation does work.